Well, it's probably been a while since you've done limits. So what I'm going to do is I'm going to do a few examples from Math 3A real quick, because there's basically three main things that happens with limits. One is you substitute the number in and it creates something that's undefined, like this one right here. In that case, we need to do some algebra. So what we could do is factor the top as x minus 3, x plus 3. Notice that this is what's causing division by 0. So the only way that factoring is going to help is if x minus 3 shows up in the numerator. With this one, it just happens to show up. You can then cancel these. Then substitute the 3. There's no more division by 0. We just get 3 plus 3 equals 6. Now another case would be if they were switched. So that way when you do the algebra, this is then going to be in the denominator. Oh, wait a second. I need to change it just a little bit. There. So when you factor the denominator, x minus 3, why did I put a 9? X plus 3. So this time the x plus 3's are going to cancel. And then it's going to leave 1 over 0, which is undefined. So this one does not exist. So it could happen that you do the algebra and you get a nice tidy answer like 6. It could be that even though you do the algebra, it still is undefined or does not exist. And then, of course, the easiest case is where you just plug in the number and you get an answer. So this would be an 8 plus 1, so that's 9 divided by 20, which cannot be reduced, so that's done. There actually is another case, and that is if you have the limit as x goes to infinity, let's say, and then it's 2x squared plus 1 over x squared plus x. So then you can do L'Hopital's rule. The top is going to infinity, the bottom is going to infinity. So use L'Hopital's rule. And for that, you take the derivative of the top, which is going to be 4x. You take the derivative on the bottom, which is going to be 2x plus 1. And then this would still be infinity divided by infinity, so go ahead and do L'Hopital's rule again. The derivative on the top will be 4. The derivative on the bottom, 2. So the answer is 2. Okay, so there's actually 4 main cases. Do algebra, get a finite answer. Do algebra, get undefined, or this is going to infinity. The easiest case, you just plug in the number and you're done. And then sometimes you need to use L'Hopital's rule. L'Hopital's rule is only when you have infinity divided by infinity at the beginning or 0 divided by 0. Now let's look at some Math 3C limits. Well, of course, we're going to have more than just one variable. So what's the limit? And it's going to be xy plus 3y minus 5x minus 15 for the numerator. The denominator is y minus 5. And then it's going to be as x and y go to 4, 5. So this is saying x is becoming a 4, y is becoming a 5. And of course right there, y becoming a 5 causes division by 0. So that's the first kind where we need to do algebra. And when you do algebra, the only thing that's going to help get rid of this division by 0 is if you can factor the top and have y minus 5 as one of the factors. So now we just need to get creative with our factoring. Okay, so this is a negative 15, so that must be that there is a plus 3 right here. That and that will give you a negative 15. Now there's also an x times y term, so if I put an x right here, then I will have the x times y. If I distribute, I'll also have the negative 5x. Distributing the y with the x, we've got that. The y with the 3, we've got that. So we've got all the parts. It worked. And then these can cancel. And now x is becoming a 4, so this is just going to be 4 plus 3. So it's 7. Next example. What's the limit as x and y approach the origin for this function? X minus y plus 11 square root of x minus 11 square root of y over the square root of x minus the square root of y. So this is saying that both x and y are becoming 0, in which case this is going to cause division by 0. So then you could factor, as I did before, one of the factors, like this one right here, would need to be the same as this, square root of x times square root of y. Well, that I could do that, but I'd basically just be repeating this example. So instead, I'm going to do it a different way. And that is, I'm going to use the conjugate. So I'll take this right here and use the conjugate, square root of x plus square root of y. And if you multiply the bottom by it, you need to multiply the top by it. Need a little bit of space here. So I'm going to do the bottom first because that's easier. So when you multiply conjugates, you just need the first one times the first one. That's going to be x. And the last one times the last one, that's going to be minus y. Okay, now distribute. First of all, I'm going to distribute this square root of x. So there would be x times the square root of x minus y times the square root of x. Then multiplying it here, that's just going to be plus an 11x. And then there would be minus 11 square root of x and square root of y. I could just put those two together in a square root. Look at that, we're already halfway done. And now distribute the square root of y. So there will be an x plus an x times the square root of y, and then square root of y times that one, so minus y square root of y. And plus, for this one, they're both in the square root, so, oops, I need to put the 11 first. 11, and then square root of xy. And then finally, this one times this one will just be minus 11y. Let's see, does anything cancel? Pienso que sí, right here and right here, these are going to cancel. Anybody else? I don't think so. But notice, this says x minus y. Yes, it does have a square root of x, but it's got an x minus y. And if you put these two together, they also say x minus y. And if you put those two together, they also say x minus y. So I could factor them in groups. Okay, there I factored the bottom. Now for the top, put these two together, and you could factor out the square root of x, and then it would leave x minus y. Now put these two together, and you can factor out an 11, and then parentheses x minus y. And then for these two, you could factor out the square root of y, and then times x minus y. Oh, that worked out perfectly. So beautiful, I don't even want to cross anything out, but I need to. Cancel, 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 cancel. So all that's left is this. All that's left is this, which is becoming 0, an 11, and this is which is becoming 0. So then it would be the square root of 0 plus an 11 plus the square root of 0. So the final answer is 11. Now, check out this next one with some trigonometry. What is the limit as x and y approach the origin for sine of x squared plus y squared over x squared plus y squared? So if you put 0, 0, this is going to be sine of 0, which equals 0. This is going to be 0 plus 0, so that means it's 0 divided by 0. So it seems like we could use L'Hopital's rule. The only thing is, how do you take derivatives if there's both x's and y's in there? Yeah, because we don't do that until maybe next week. So we can't do that. How about if you change to polar coordinates? Remember from Math 3B, polar coordinates? So basically you're just using trigonometry, and you say if you have a right triangle and this is x and this is y and this is r, then I can do things like x squared plus y squared equals r squared. I could also do sine of theta, tangent of theta, etc., but this is the one that I want. So change it to polar. So it's going to be the limit, and then replace x squared plus y squared with r squared. And since x and y are becoming 0, that means that this triangle is shrinking down and down and down until it disappears to be nothing. That means that the r would also be going to 0. Or just right here, if these are becoming 0, then r is becoming 0. Then this is becoming a 0, so sine of 0 equals 0. This is a 0, which means we could use L'Hopital's rule. And now we only have one variable. So on the top, the derivative of sine, that's cosine. Now do the chain rule. The derivative of the inside would be 2r. On the bottom, the derivative of r squared would be 2r, which is a great opportunity for the red pen to come in and say those guys cancel. And then all that's left is this is becoming 0, so that means that it's cosine of 0, and cosine of 0 equals 1. Ta-da! Okay, so with all of the ones that I've done so far, they've all had an answer, but sometimes they don't have an answer. Sometimes the limit just does not exist. Now remember from Math 3A, the way that a limit could not exist in Math 3A is if the function goes like this. Let's say you're taking the limit as x approaches 3, and then the other side looks like this, and there's this gap in the function. So then the limit as x approaches 3 does not exist. Another possibility would be like if it went to infinity or negative infinity. Now, if both sides actually go to negative infinity, I would say the limit does exist and it equals negative infinity. But when the two do not agree, that's when you say does not exist. All right, so for the next one, find the limit as you approach the origin. And this one's going to be x times y over x cubed minus y squared. So this is causing division by 0. In fact, it's going to be 0 over 0. And with two variables, I can't just pull out L'Hopital's rule. And with it cubed, polar doesn't really work that great with a cubed. It's really helpful when you've got squares. So that's not going to work. Okay. So here's the xy axis, and we're supposed to be having it approach the origin. So what you do is you pick any graph from pre-calculus, any graph that goes through the origin. I'm just going to use an easy one, like the line y equals x. That goes through the origin. So this is going to be called path number 1. So for path number 1, use the line y equals x. So in other words, this is going to become an x, and this is going to become an x squared. So then we're basically now making it one variable as x goes to 0. On the top it would have x times x, so it's got x squared. And then it would have x cubed minus x squared. And then for this one, I could factor the bottom. So on the bottom, you could factor out x squared. It would leave x minus 1. You guessed it, red pen time. These cancel, it leaves a 1 on top. So now when x becomes a 0, this will be 0 minus 1. So it's going to be 1 divided by negative 1. So the answer is negative 1. Now, I tried to make the problem up so that it's like this. So you'll get two different answers. So pick another path. And this time I'm going to use a parabola. The parabola y equals x squared. That goes through the origin. So use y equals x squared. So it's going to be limit as x goes to 0. Y is going to become an x squared. So this will be x squared times x cubed. On the bottom, it's going to be x cubed. And now put an x squared in here. That means it's going to be x squared gets squared. So that means minus x to the 4th. And again, we could do algebra and factor on the bottom. You could factor out x cubed, and then it leaves x, oh, hold on, it leaves 1 minus x, right? Because we're factoring an x cubed, so it leaves behind 1 minus x. And then the red pen says, it's my turn, cancel these out, leave a 1. And then when you substitute the 0, this will be 1 minus 0, which means the answer is 1 over 1. So sure enough, there's two different answers. So the final answer is it does not exist because like this, I got two different answers. Since the two paths do not give you the same answer, then the limit does not exist. And then there's one other idea in this section, and that is, where are functions continuous? So for example, f, a function of x and y, is equal to sine of 1 over xy. So for a function to be continuous, there's basically just two things you have to watch out for. One is division by 0. The other is the square root of negatives. Because we do not use imaginary numbers in calculus, although it's possible, definitely possible, but that's an upper division class. For Math 3A, 3B, and 3C, we do not use imaginary numbers. This, of course, does not have any square roots, so we don't have to worry about that rule. but it could be division by 0. So where is it continuous? Well, if x equals 0, it's not going to be continuous. If y equals 0, it's not going to be continuous. Any other number would work. So everywhere except x equals 0. Actually, this should be the word or. Y equals 0, because if I put an and, that could imply that they both have to equal 0 at the same time. Or could mean this one equals 0 or that one equals 0. So in other words, if you look at the xy plane, the red part is where it's undefined. Everywhere else, the function will exist. So just take out where x equals 0 and where y equals 0. Let's do one more like that. So this time the function is 1 divided by x squared minus the square root x plus y. All right, this one has a square root. So that means that whatever's inside the square root needs to be a positive number. So we need x plus y. Actually, it could equal 0, because if this equaled 0, as long as this doesn't equal 0 at the same time, so bigger than or equal to 0 with x not equal to 0. So that is part of it. Now the other part of it is you can't divide by 0. So also the bottom part, x squared minus the square root of x plus y, could not equal 0. Or in other words, x squared cannot equal the square root of x plus y. And then that's basically it. Now I do want to do one more, and that is, after looking at the homework, they also did something like this. Find the limit as x and y goes to 0, 0, and then it's going to be 2x over x squared plus y squared. And one more, practicing changing to polar form. So as I said before, polar is basically just setting up a right triangle, and then you can use the Pythagorean theorem to have x squared plus y squared equals r squared. Now this one has x by itself, so I need to see what x equals. So I could use cosine. So cosine would be x over r, or in other words, x is equal to r times cosine of theta. Okay, so then we would have the limit, and on the top it's going to become 2 times x, so 2 times r times cosine theta, and on the bottom x squared plus y squared is r squared, and then this would be as r and theta go to 0, each one, because again, if x and y are going to 0, this triangle is shrinking down until it becomes just a dot. And so both r and theta would become 0. Now on the homework, they said to just set it up, but I still want to try to do this one. Let's see. An r will cancel an r, And then this is going to become cosine of 0, which equals 1. So it'll be 2 times 1 on the top. And then r is becoming 0, so that means that it's 2 divided by 0. Now, if it was 0 divided by 0, I could use L'Hopital's rule or something like that. But for a 2 divided by 0, that does not exist.